Welcome back. So I wanted to give you guys a quick status update on JCM-1 and where I am with the project. I've been ruminating over the keyboard a little bit more in ways that I could potentially improve that. The main goal here is having a keyboard that is actually some sort of real kind of keyboard that still uses the original design that I put together and isn't a cop-out of just plugging a PS2 or USB keyboard into the system. So I've come up with a plan and done something with that to make that happen. Now, let's take a look at the original design here. You know, it was the microcontroller with an array. It scans the array, it sends the data out to the computer, and that's basically all there is to it. Went over that in the previous video. I kept that same logical design, but I went with changing where some of the hardware lives and changing the actual design of the keyboard itself. So, let's take a look at what I've done. To start off with, on this keyboard here, on the original one, you can see that the support logic has been removed from this, and I have a little external cable. And why is that? Well, as part of the keyboard redesign process, I moved the support logic off of the keyboard and into its own board. Now this board is eventually going to live over here on JCM-1 proper, but for my testing and design purposes, I gave it its own little board just for that purpose. Basically, we can take the connector cable that I have wired into the keyboard here, plug that into this connector right there, and effectively what that's doing is that's connecting the microcontroller to the rest of the support circuitry via this nice long cable instead of using wires on the back. And what is the reason behind this? Well, I wanted a keyboard that could be its separate unit and that could plug into JCM-1 through a cable. Now, one of the options that we could do to do that is to take all of the original bus lines and make a really long bus cable and plug that into the keyboard. But the problem is this is the data bus. This is the 6502 data bus. It does not like being long cables for impedance and noise and all of that stuff. And I would have had to put like weird transceiver buffers and all this other stuff in it, and it was silly. So let's not do that. What we've done instead is we've separated effectively the serial logic here from the keyboard. So the keyboard, I guess you would call it, the keyboard interface logic will live on JCM-1, and only the microcontroller lives on the keyboard. That way the microcontroller can talk to JCM-1 over a simple serial connection. It's not RS-232 or anything crazy like that. It's just a serial bit-bang line port thing that goes blah, 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 and it sends the data over there, and that's how it works. So I wanted to set that up and test the theory of that physical operation before I went ahead with building the new permanent keyboard for JCM-1, and that works. Now, looking at this connector, for right now, it's just 8 wires here. You know, it's basically Ethernet cable with 8 pins connected into an 8-pin socket in a row, and I have to make sure I get my orientation correct, or else I'll fry things. But you know, that's no big deal. The reason I went with this specific setup was for ease of design while I was making it or putting it together. But when I was separating the serial section from the keyboard itself, I found that I needed exactly 8 wires. And what has 8 wires and is ubiquitous that I already know how to use? That would be Ethernet cable. So I got a piece of stranded Ethernet cable, 6 feet long, wired it up, and there you go. So in future, if and when I get JCM fully completed, we can use a standard Ethernet jack as our connector for our keyboard and just plug it in and Bob's your uncle. So it makes it real simple. We could even just use an Ethernet connector on both sides and just use any standard patch cable and just go pink and plug it in and it would work. So I thought that was kind of pseudo-genius. I liked that idea, so that's why I went with this way. Pre-packaged cable that comes in lengths that I can cut to the way I need it. I can terminate it as a regular Ethernet cable, or I can just use a patch cable, whatever. Easy peasy. So, as it stands, this design here functions identically to the way it did before. The controller, the code on the controller is no different. It does exactly what it was supposed to do before, and it functions like it did, but that's not the end of it. Let's bring in what the new keyboard design looks like. And there it is. This is one of those custom keyboard kits. This is a Tada 68 that comes from some Chinese keyboard website, which I will link in the description below. But the Tada 68 is a custom keyboard kit that you can buy all the bits and pieces and make your own keyboard. Now, I didn't buy it to make a regular USB keyboard, because as you can see here, I've got the PCB for it. I know I didn't even use it. It wasn't useful to me for this project. What I wanted is I wanted all of the rest of the guts of the keyboard. I wanted the key switches, I wanted the key caps, I wanted the backing plate and all the articulation materials, and the base so that I could wire up my own keyboard matrix. And that's what this is. Now, I could have tried to find some old mechanical keyboard and hack that up and wired that, but no, I didn't want to do that. This made the most sense to me. It came with everything I needed to wire my own custom matrix and wire it basically identically to the way it was in the regular custom keyboard. So this functions identically to the other keyboard from the perspective of JCM-1 anyway. Basically, we got our same 8-pin connector. It plugs in the same way. And it sends data to JCM-1 identically. I didn't have to change any of the ROM code on the computer itself. Didn't matter. But what is different is the keyboard itself. So we're going to flip this open very carefully. And there is the keyboard. So I have this matrix wired up almost identically, with the exception of I did remap the keys a little bit, and we have the keys on the right-hand side, page up, page down, and things like that, function and win. Those didn't exist in my previous design, so I had to incorporate that in there, but the code change was very minimal. So we got that all connected. We have our rows connected right here via this set of wires, columns connected right here via this set of wires. Also, these are also columns. I just followed the standard resistor color code and then repeated the code again for the extra lines. This right here is our caps lock light, which is right over here. It's just kind of shoehorned up underneath here under the caps lock light. So when you turn caps lock on, that light lights and you can see it glow through the keyboard. And then we just have our interface cable right here that goes from the microcontroller board out to the computer. Now, the microcontroller that I decided to use for this is the little brother of the big PIC microcontroller. This is the 18855 microcontroller. It's programmable, usable in the exact same way. The code on here is almost identical to the other one, with the only exception being that I changed the code to reference the different pin names that I was using, and a few of the control registers were modified because this functions slightly differently, just a hair. But other than that, the code was pretty much identical. Slap that on there, and there you go. Now, the reason I use this is because this chip is a lot smaller. It would fit in this keyboard very easily, and I wanted this part of the controller to be able to just kind of snug right up in here, hide out of the way, and be done and over with. So that worked really well. I could even take a Dremel and cut this off right here to get it even smaller, and then double side tape it in. And I haven't done all that because I wanted to show you what it looked like before doing all that. But yeah, it's got our pull-up resistors along the side for our columns. Our rows don't need pull-up resistors because those are the drive lines. Our decoupling capacitor, and that's all there is to it. Just ties straight to the rest of the keyboard logic hiding up in there, and that's it. Now, to make a little room in here for the cables in the back of this, and also because this has some thickness to it, and I had to compensate for that thickness, I did add some extra little headers here, some spacers, to lift the keyboard up out of the way with washers so that the keyboard could sit down on it, because this project is designed really just kind of to lay together and not really sandwich together. So the washers meshed in there or shoved in there help the keyboard backing plate here have some place it can sit down on. And so, as you can see, it just easily goes right back together, just like that. Super simple. This kit ended up being super helpful to me. I looked for, gosh, a week trying to find a kit that had all the bits and pieces I wanted to do this that was relatively inexpensive. This kit was something like 115 bucks. Is that expensive? Yeah. But I wanted my own gosh darn keyboard, so don't judge me. Whatever. So yeah, now that that's all together, let's show the keyboard in action through the serial terminal. So hang out for a bit, I'll get that set up, and we'll hop over there. So I have JCM-1 up and running here. I'll hit enter a couple times, and you can see on the screen that the regular keyboard input is working. So let's go ahead and change over to the new keyboard and test that out. Awesome! So the new keyboard works just as well as the previous design did, except for the fact that it's a full travel clicky keyboard and I can type on it. And listen to the clickies. Listen to how it clicks. Ah, it's delicious. Excellent. So yeah, I just want to give you a quick status update to show you where I was. I wanted JCM-1 to have a real, true keyboard that I could use that wasn't some PS2 or USB cop-out. It's got its own keyboard controller, its own keyboard protocol, and its own custom keyboard. Well, that's all for today's episode. Coming up soon, we're going to start working on the video output. That's going to be great. Yeah, if you guys have any ideas of how I should do that, leave comments below. I'm not sure how, what, or exactly I want to do there, but I'm going to figure it out as I go. If you like my content, go ahead and subscribe to my Patreon if you want. Drop $1 in the cup, get access to these videos early, and get your name in my videos, and even doodads and trinkets at the higher levels, you know. And that's all there was for today. While you're here as well, check out some of my other videos. Hit all the little YouTube-y, likey, subscribe-y bell stuff. That really does help out the channel. It helps the analytics and stuff know that, hey, Joe's got some new stuff for you. Thanks for watching, and remember, 8 bits are all you need.